well, thank you so much for being here. It is my great pleasure to welcome Josh Schneider here. It's actually the second time you come to the Loughborough London campus, right? I think the first time was in January 2018, so 2 years ago. So thank you so much for being here today. So Josh Schneider is the acting university archivist at Stanford University Libraries, and he's also the former community manager for the EPAD project. So I'm sure many of you are familiar with the EPAD project, and obviously well-known project. It got an award in 2018, the DPC Award, Digital Preservation Award. So that was a great award, really. So I think we can start. So you have a new title, I believe. So I'm just going to leave you here. Thank you.
Great. Thank you. Thank you, Lise, and thanks everyone for the opportunity to speak with you at Loughborough. Josh Schneider, as Lise mentioned, I'm currently acting university archivist at Stanford, where I acquire and support the provision of access to materials in all formats, comprising Stanford administrative records, faculty papers, set up there. And other materials documenting community and student life. I've also served as community manager for EPAD, which, if you're not familiar, we'll learn more about it. It's open source email archiving software that incorporates natural language processing and machine learning. Stanford Archives and the libraries more generally holds rich collections of digitized and born digital text, manuscript documents, photographs, maps, and much more beyond email. We're committed to providing broad discovery and access to our collections. We want people to use them. But even at a well-resourced institution like Stanford, the scale of our collecting and our limited staff means we need new ways to augment our workflows to describe our collections and make them discoverable and accessible, in line with evolving expectations of our users. And we're obviously not alone in exploring the adoption of AI and ML for those purposes. We've learned today about some examples of how AI and machine learning are already being used to improve discovery and access to archival collections. Probably the most comprehensive approach provided thus far to attempting to address these questions systematically in libraries is the new report by Thomas Padilla at OCLC Research, Responsible Operations, Data Science, Machine Learning, and AI in Libraries. Padilla reported on research conducted through 2019 in the United States and specifically describes the interdependent technical, organizational, and social challenges that will need to be addressed en route to library operationalization of data science, machine learning, and artificial intelligence. Padilla highlighted the consensus that doing this work responsibly requires fostering organizational capacities for critical engagement, managing bias, and mitigating potential harm. A tool has no impact without a hand to guide it, and the library community gives these technologies and methods purpose in alignment with their values. So I'm really excited about the role that data-driven technologies can play for libraries, archives, and museums across the board. And I'm going to focus on a few early examples I think show the promise to improve access to our collections. I also want to use this opportunity to highlight the role of and risks to the people behind and in front of the AI lens. I'm especially going to be talking about the work of archivists and the archival labor that enables cultural memory, machine learning projects. And I'm going to be talking about how contextualization and collaboration provide a thread by which to navigate this space and appreciate and evaluate the opportunities and the challenges. So the first point that I want to make is that when we consider the role and impact of artificial intelligence or machine learning, we should be mindful that the labor underlying these technologies, for supervised machine learning especially, is predominantly human labor. Ethically seeking out, accessioning, processing, and managing collections, digitizing and describing content, contextualizing data and bias, creating training data sets for model benchmarking, building and managing preservation and access repositories, designing our interfaces, maintaining our code bases, building successful collaborative teams and shared community resources, and managing relationships with the individuals whose data are included in our collections is very labor intensive, including emotionally labor intensive. And when it comes to AI projects, much of this work is hidden. I think this point bears stressing here because as Stacy Williams, director of the Center for Digital Scholarship at University of Chicago reminds us, cultural memory operations take a lot of people to produce the highest level work. In recent memory, the work of cultural heritage staff has been hidden and ignored, defunded, and marginalized. Of course, the primary goal of the adoption of these technologies is to make our collections more accessible. But to paraphrase Cliff Lynch, director of the Coalition for Networked Information, to the extent the state of access to our collections is poor, it's primarily due to the lack of resources to hire people to arrange and describe collections. Now, there are indications these technologies can create some truly transformative opportunities for research, as well as provide broad support for individuals with visual or audio impairments. But we should consider that the mass undertaking of AI initiatives will have a huge impact on archivists and is likely to amplify current trends rather than reverse them. Archival labor and contextualization, including via arrangement and description that incorporates the voices of the individuals and groups who created or collected the materials, is largely maintenance work. There's been some great recent work in the past few years exploring how archival labor aligns more generally within information maintenance work, which emphasizes the labor of continuity at the intersection of information technology, infrastructure, and repair, as well as feminist care ethics, which, among other things, highlights the role of effective understanding, real relationships, and the importance of specific contexts. Archivists perform crucial maintenance of records, information, relationships, societal memory, and accountability. From this perspective, archivists can and should bring a critical eye to technological disruptions like AI and the techno-chauvinism, to quote NYU journalism professor Meredith Broussard speaking in a different context, that fosters the flawed assumption that tech is always the solution. And we especially need to consider how the development and adoption of these technologies can not only obscure the labor of cultural memory staff, but following the lead of Princeton professor Ruha Benjamin and others who've written in this space, we need to consider how these technologies can both obscure and further exacerbate asymmetrical power imbalances of gender, race, and class in our institutions and the broader society. But first, I want to make a quick point. The exploration of data-driven technologies in libraries isn't really new. We've been incorporating these ideas under the radar for a long time. As our DH friends here know, Roberto Bussa was a librarian in the mid-1940s, around the time he convinced Watson and IBM to fund his Index Thomisticus, a massive attempt to encode nearly 11 million words of St. Thomas Aquinas on IBM punch cards. And while LAMS, libraries, archives, and museums, may be lagging behind some other fields in AI adoption at the strategic level, data-driven technologies have been actively adopted and applied to cultural memory objects by many universities through projects and programs in the last 20 to 30 years, including in digital humanities labs and especially around Chinese religious texts. So with that in mind, I'm going to talk about a project I'm familiar with, EPAD, which is developed by Stanford Library's Department of Special Collections and University Archives with funding provided by Mellon, the U.S. Institute of Museum and Library Services, and the U.S. National Historical Publications and Records Commission. Over the past 8 years, EPAD has pioneered the application of natural language processing and named entity recognition to address challenges of screening and providing meaningful access for large volumes of email of potential historical or cultural value. The software enables donors, curators, archivists, and others to manage privacy, copyright, and other policy and ethics concerns, and provides researchers with new modes of discovering and conducting research with these collections as data. EPAD has been adopted by dozens of cultural heritage institutions to appraise, process, and provide access to email. EPAD was designed with extensive donor, curator, and researcher input and managed by digital archivists in collaboration with a dedicated computer programmer and advisor, Sudhindra Hengal, a Stanford computer science PhD. The software includes a custom fine-grained named entity recognizer that extracts fine-grained types of entities bootstrapped from English language DBpedia. These include persons, organizations, locations, government entities, political parties, companies, universities, diseases, and awards. Named entity recognition effectively converts unstructured data from the email message body into structured data, which can be queried and browsed. At the same time, retaining the email as email provides necessary context for researchers to understand it. There are a few ways in which EPAD has been, I think, especially innovative relative to our discussion. First, it includes a module incorporating the named entity recognizer that's creator-facing. That module gives individuals who are interested agency to review and screen their own email for sensitive content in collaboration with a curator and archivist before transferring it to a repository. This means repositories are able to collect materials which they might be otherwise unable to, since fear of inadvertently sharing sensitive content is one of the primary reasons why donors are hesitant to donate or transfer mail. The labeling functionality appears in 3 of the 4 modules and is the primary way in which message restrictions are managed. We've also considering adding a suggestion engine that learns based on your labels and suggests messages that might be similar, or for example, that might be sensitive. This functionality that's mature in other contexts is an area that libraries are already adopting outside of archives and would be great to incorporate across modules. I want to pause here and recognize that collections in EPAD don't process themselves. Rather, EPAD serves as a force multiplier, a power tool that helps donors, curators, and archivists screen email for sensitive data and contextualize that data for others. We've been rather fortunate that we've been able to rely mostly upon permanent staff, with the exception of our software programmer and advisor, to pursue this work, in addition to our other responsibilities, but many other projects rely upon contingent, grant-funded staff in a way that can exacerbate labor issues and staff precarity within our institutions. Discovery of email in archival collections by researchers is another challenge, since email is not often made available online to the public due to donor and third-party privacy and copyright concerns. As description is made available online in archival finding aids and catalog records, and that description, though, is often very limited, it can be difficult for researchers to determine if they should travel to the host institution to view the materials in person. To address these issues, EPAD also introduced an online discovery module. That module is mounted on a public web server and enables researchers to access a redacted version of the email archive prior to visiting the repository. This is what researchers can see online, and this conceit inverts the traditional model of redaction by displaying only the correspondence and named entities. It relies heavily upon EPAD's automated resolution of correspondent names and extraction and classification of fine-grained entities. And this reverse redaction provides researchers with much more information and context than those traditional finding aids and catalog records, with which to decide whether to visit a physical reading room to access the full corpus. The discovery module enables even those remote users who are unfamiliar with the collection to browse across it via these same correspondence and entities. Once a researcher has discovered the email archive and decided to view it, they can use EPAD to enable, a repository can use EPAD to enable access to the full archive of unrestricted messages, including attachments via discovery module that offers many of the same functionalities included in the other modules. EPAD also supports a variety of exports of controlled data from the archive to support accessing collections as data, including topic modeling and network analysis. Part of what has made the broader adoption of EPAD successful may be that it was designed to be generous for folks who may not have any technical background to explore and take actions on their mail. One other function I want to highlight in EPAD is multi-entity search, which aids in comparative entity analysis between the archive and any other textual corpus. Matching entities are highlighted and linked to the message results. This, to me, is one of the more interesting functions to come out of the project. Imagine a federated service offered to researchers that ingest their articles or articles they've read and appreciate and recommends or matches above a certain threshold from the latest cultural memory data to be processed and made available by archives worldwide. Of course, entities aren't the be-all, end-all of extracting relevant data. Compare EPAD's functionality for entities to that enabled by Hamlet, created by Andromeda Jaillant, which uses machine learning to power experimental exploratory interfaces to the MIT thesis collection via concepts based on paragraph vectors, which extends that popular word-to-vec algorithm we heard about earlier, developed by Thomas Mikolov's research team at Google in 2013. Hamlet lets researchers ask new questions, which in Jaillant's words are both semantically interesting and mathematically meaningful. Like, what do you get if you take Star Wars and add more gender? Or what if you start with ancillary justice and take out the stuff that's also in Left Hand of Darkness? What book is most like the parts that remain? Again, these are amazing questions we weren't able to ask or answer in the past, and they similarly rely upon the labor of humans that seed the data, that accession, process, digitize in the case of non-digital materials, QC the data, and maintain the systems that host, preserve, and provide access to it. So data-driven technologies and even machine learning and AI in libraries isn't exactly new. What is pretty new is how LAMs are more visibly and critically considering what it means to further adopt these technologies to meet their challenges and needs and extend the discoverability and use of collection materials in new ways. Libraries are also more focused on the whole ecosystem. Donors, curators, archivists, librarians, digital preservation and data folks, industry and researchers, like with the EPAD example. This is critical and highlights the importance of approaching this work collaboratively across institutions and across disciplines. Communities are forming in this space to discuss AI, including via Code for Lib and the AI-dedicated AI for LAM, which is meant to serve as a collaborative framework for libraries, archives, and museums to organize, share, and elevate their knowledge about and use of artificial intelligence. Nancy McGovern, Director of Digital Preservation at MIT, has used the notion of radical collaboration to describe how individuals can come together across disparate but engaged domains in ways that are often unfamiliar or possibly uncomfortable to members of the organizations and individuals in order to identify and solve problems together to achieve more together than we could separately. In the past couple of years, under the leadership of my colleague Nicole Coleman, Stanford's research architect, the library has been experimenting with how to effectively design teams to address both technical and domain knowledge aspects of this work in line with that sensibility. I've been involved with 2 projects, experiments applying speech-to-text recognition on archival audiovisual recordings, as well as automated image clustering and classification for photo collections to support collection development. I'm going to talk very briefly about each of these in the context of the other work that's also happening in this space. That first project, focused on audio transcription, was aimed at the papers of American poet Allen Ginsberg, which are held by Stanford, and include sound recordings that document the birth and development of many of his ideas. To support a dissertation by a doctoral student in the English department, a team including a digital archivist, curator, and computer programmer worked on running speech-to-text on 72 hours of digitized recordings. When Ginsberg was writing poems, he would turn the tape recorder on and off. Our doctoral student found that those breaks, which you can hear, often correspond to the start and stop of the written poems. And at a larger scale, there's a pattern reflected in the recordings over the course of his travels around the country, where he would be on the bus recording, stop at a town to give a reading that was recorded, then get back on the bus and record. So we worked on this project and other audio recordings like it using Google's speech-to-text algorithms. And in our early experiments, we honestly weren't tremendously successful. Google speech-to-text is trained on contemporary audio for commercial purposes, and the domain adoption to our archival audio was just too poor. We weren't successful enough, we thought at the time, to share those transcripts online. We don't have the discover or access infrastructure to convey relative levels of confidence, and we're not yet confident enough in our own ability to convey mixed confidence transcription to our researchers. It's an interesting area of development, though. But the experiment was successful enough that we could give the graduate student a much better sense of what's in the collection, which made her happy, and in that way it was a bit successful. The alternative in this case would have been the graduate student listening to all the audio herself, which was of course unlikely to happen. And speech-to-text, like image classification, provides huge opportunities to improve discovery and access for people with auditory and visual impairments. We just scratched the surface on this experiment. It enabled us to begin to consider what incorporating that speech-to-text might mean for our workflows and discovery interfaces. Also, many of the commercial tools are experimental and subject to frequent change with very inconsistent documentation. That can complicate providing context. If we were going to share the output to encourage diverse captioning, we would presumably also want to share that the algorithm was generated using a particular version of a particular engine. Brandeis University's Lab for Linguistics and Computation are way ahead of us here. They're developing a toolkit for the WGBH Library and Archives, including for the American Archive of Public Broadcasting, that allows archivists to drag and drop media files into a system of speech-to-text, entity recognition and extraction, metadata normalizing, and automated ingest, and are also developing a public interface. The second research project I was involved in at Stanford was focused on applying out-of-the-box image classification algorithms to attempt to gather useful image classification data for images in our collections. I'll note these tools are freely available online, and that many have conducted similar experiments, and we learned today that Frick and Getty have been particularly innovative in this space. Again, the commercial services available to us offer results that cater to business applications rather than the needs of lambs. The experiment surfaced many interesting ideas and directions, including around how these tools might inform collection development and metadata creation. We formed a collaborative team here initially, but the time we would each spend on the project was limited differently due to how the workforce is managed at our institution. Our engineers needed to plan around ongoing software sprints and want to get as far as they could as quickly as they could with limited context shifting. They developed a pathway for folks to use the International Image Interoperability Framework, or IIIF, URLs to apply Google Cloud Vision. On the other hand, our metadata librarian and archivist want to spend additional time exploring how these tools might be used to supplement our existing metadata infrastructure for archival images. We're asking questions like, could these tools be used to train algorithms that will provide approximate dates for photographs? Or could image matching across institutions be used to drive copy cataloging for our image collections? So this was an example where our attempt at radical collaboration was unsuccessful due to differences in how work is managed across the institution. But we still took a lot from the experiment. The role of the archivist in cases where metadata from these services is applied could be to sign off on description generated above a certain threshold of confidence, or to make higher level ethical and policy judgments. I mentioned the International Image Interoperability Framework earlier. Stanford's a big driver behind that collaboration, which includes both a series of APIs and communities that can support cross-institutional exhibits and storytelling with archival materials split across multiple institutions, visual search and analysis, user-supplied annotation, and more. In the ML context, IIIF could potentially provide the technical underpinnings to federate images as data and help enable cross-institution benchmarking data to drive the creation and application of algorithms appropriate for cultural heritage materials. Both the experiments at Stanford I participated in explored the adoption of commercial cloud services to replace or supplement activities currently performed by people. Many folks, like Dan Cohn, Vice Provost and Dean of the Library at Northeastern, are considering whether AI-driven technologies can help achieve good enough archival processing, or whether the trade-offs to cultural heritage institutions are too great. Nicole Coleman, peering beyond the AI hype, thinks when this technology is truly ubiquitous, the quality of results will be the focus of attention, and reliance on library expertise will be even greater. Let's talk for a minute about quality. If you're not familiar with ImageNet, basically computer scientist Fei-Fei Li and her students scraped images from Flickr and a few other places on the web, sent them to Amazon's Mechanical Turk, where thousands of humans with zero expertise added keyword descriptors of what appeared in the images. Then the images and labels were added online to this site, ImageNet. So the human-labeled image store has been a huge part of the AI revolution. Models trained on ImageNet and using deep learning have gone so good at approximating the human-applied labels that the industry has stopped giving out benchmarking awards for most precise image labeling algorithms. Sounds great, right? Unfortunately, there are a lot of problems, some of which we heard about today. First off, a lot of the images are garbage. 2/3 of the images are from the global West, and the keyword labels are predicated upon the biases of many thousands of human contributors. Meanwhile, libraries have fantastic cultural memory collections with metadata that's been painstakingly applied. I mentioned that archivists and metadata librarians have provided and will likely continue to provide the labor to train algorithms for library cultural heritage materials. But it's not like training algorithms in our materials would be a golden solution here. A cultural memory ImageNet based on collections currently digitized or born digital and tuned for computation would still suffer from underlying structural issues. It would still represent largely Western institutions and would also, as several have noted, reflect biases in collection development, overrepresenting some dominant communities and underrepresenting marginalized communities. Cultural memory institutions, in this case, can pursue and encourage the development of corpora that remediate underrepresentation and identify and contextualize biases for their data and models, including through recording the provenance of the data. A good time to take a break with a video. Almost as an analog to the multi-entity search MIT concept vector mapping we considered earlier, a few folks have come up with search interfaces that enable users to explore similar images across vectors by uploading a particular image, or image set. Some of the coolest examples of this work are from the Yale DH lab. Monica Ung-Reid, Doug Duhame, and Peter Leonard explored various ways of seeing 27,000 images from the Meserve-Kunhardt collection, one of the largest collections of 19th century photography in the world, housed at the Beinecke. In the Neural Neighbors project, they ran the images through a neural network and then aggregated images based on the penultimate layer of that network across 2,048 vectors of seeing. This has also seeded the PixPlot discovery environment seen here, which aggregates similar image files into raw categories, which can help support appraisal and description at scale and improve discovery. Again, we have clusters but no labels, almost like a series of topic models. Some may be helpful, some may not be. This is an opportunity for curators and archivists and metadata librarians to apply their expertise to develop new descriptive categories and dream up new user interfaces. In the DH space, one of the most compelling examples I've seen of these technologies is the Distant Viewing Lab at distantviewing.org. The lab engages closely with critical cultural and data studies, aiming to make explicit the interpretive act of algorithmic logic. Of course, there's also recursive and dark aspects of this technology. Generative adversarial networks can be used to create images of faces for people that don't exist, which can be used to seed fake profiles on social networks. Apparently, this is the one example of fake political discourse that actually does break Facebook's terms of service. Facebook just isn't a fan of the unethical use of algorithms. That was my one zinger. As the CFP for an upcoming conference on critical algorithmic studies noted, efforts to historicize, culturally situate, and foreground algorithmic systems as manifestations of bias and power are flourishing recently. Libraries and archives are thinking more critically about algorithmic influence in our lives and the amplification of negative bias that could adversely impact library staff, users, and society. Here, many are looking towards scholarship on algorithmic bias and accountability by groups like the Algorithmic Justice League and scholars like UCLA professor Sophia Noble. In Algorithms of Oppression, Noble examines the way search engines, which underpin our lives and how we determine relevant information, misrepresent a variety of people, concepts, and types of information and knowledge. And she puts a spotlight on how the algorithms that drive these pervasive tools lead to further oppression and marginalization of primarily women of color and do a disservice to understanding complex ideas about society. Archivists have a major role to play here. Michael Ridley, PhD candidate at Western University, situating explainable AI, or XAI, in the context of privacy, opacity, and trust, in a recent report by the Association of Research Libraries on Ethics in AI, highlights that as key stakeholders in the scholarly communications ecosystem being significantly disrupted by artificial intelligence, research libraries have a unique and important opportunity to shape the development, deployment, and use of intelligent systems in a manner consistent with the values of scholarship and librarianship. In his conclusion, Ridley emphasizes how the role of the archivist should include algorithmic accountability because of its centrality to emerging practice. That aligns with Padilla's takeaway that workforce development needs to be a key consideration of responsible operations in libraries. So these are big topics. At Stanford, we're considering next steps for local and collaborative projects and asking how to approach this work responsibly in a way that both elevates and protects our staff, our donors, and the communities we serve. We've learned that the biggest challenges in this space for cultural memory institutions are not primarily technical, but social, structural, institutional, educational, and above all, ethical. At the same time, many of the tech companies that develop and deploy the algorithms that run our lives are coming under scrutiny due to algorithmic and data bias. This is a crucial time for archivists to ensure they're driving the development and application of these technologies for the materials they stored in a way that ensures the safety of our donors and staff while meeting the evolving needs of our users. In order to do that, we need to rise to the challenge and adapt our methods to these new technologies and new opportunities. As we consider the labor of those that enable AI projects, we would do well to think critically about why we are undertaking these activities. I would argue it's the role of everyone in this room to continue to problematize this space, to continue to approach this work critically, and to get very explicit about how to best go about developing collaborative approaches that embody and evolve the values that will enable us to responsibly undertake this work. Thank you.